All right. So all of these are ions that have more than one atom, and it has an overall charge. Now, most of these are going to be negative ions, but there are a couple. Actually, if you look on your list of ions that I just gave you, there's actually only one that's listed on there, and there's really only like 2 polyatomic ions that are like super common, and that's this one, H3O plus, and then NH4 plus. Everything else is going to be a negative polyatomic ion. So here's how we would draw the Lewis dot structure for something like this. All right, so let's take this. This is called hydroxide, and you can figure that out if you look at your polyatomic ion list. So hydroxide. Anybody ever heard of like sodium hydroxide before? Maybe. So hydroxide is a pretty common polyatomic ion. What you have here, you're going to put oxygen. How many valence electrons does oxygen have? 6. So go ahead and put your 6 valence electrons. All right. Now, you got 1 hydrogen. How many electrons does the hydrogen have? It wants to. It's only got 1, though. So hydrogen is going to come in one of these spots, and it's going to bond. Now, that's all you have. However, it has a negative charge on it. What does that mean? Ben? It has more electrons than protons in this case, and really what it means is that it has gained how many electrons? A -1 charge would mean a gaining of 1 electron. So this is how many it would have if everything was neutral. However, it's a negative charge, so that means that you have 1 more electron than you normally would, so just go ahead and put that electron there and fill it up. Now, you have to put brackets around this whole thing and put a negative charge on it to indicate that it has a -1 charge.
So basically, if it's a negative, then it's going to be...
Yes.
Wait, so how do we know it's negative?
It's negative because it gained 1 electron.
So
So it's
negative.
the opposite, basically.
Look, you have to think, okay, like normally you have equal numbers of protons and electrons. If you gain an electron, that means that the negative charge goes up. So that means it's an overall negative charge.
Need another electron that's negative.
Well, it tells you that it is a negative charge right here. So you know that it gains 1 electron. See that little negative sign right there?
Yeah.
Okay. That tells you that it gains an electron. Now, where does it gain an electron from? It would gain it from a cation. It's not just pulling it out of thin air. It's gaining it from another atom. That's just not shown. All right. Let's look at H3O plus. This is something called the hydronium ion. All right. What do you think is going to go in the middle here? Oxygen. Hydrogen will never go in the middle. And oxygen has how many valence electrons?
0.
Say 0?
No, because it's positive, so it's losing.
It's 6.
It's 6.
It's still, it would start with 6.
Oh wait, I was thinking of 500. But it has 5, right?
Well, the oxygen has 6. And then you have 3 hydrogens.
But I thought if it was positive, it was
It will. We're getting there. So you have 3 hydrogens. So one of the hydrogens will come in and bond right there. Another hydrogen is going to come in and bond right here. Now, you have this third hydrogen that has 1 electron, right?
Yeah.
Does it have any place to bond? No. But what happens is some other, it would be an anion, would come in, rip off that electron from the hydrogen and leave it without any electrons. Now that hydrogen can bond in one of these 2 spots.
So I can just put an H next to the
you can put an H next to one of these. So what your final product will look like is going to be this right here. And since it lost an electron, it has an overall positive charge.
So if it loses, it's positive. If it gains, it's negative.
Right. Okay. Now, right here, this is called the ammonium ion. That's on your chart. Okay, what do you think is going to go in the middle here? Nitrogen. So nitrogen's going to have 5 electrons in its outer shell. All right, 3 of these are easy. You got one hydrogen that's going to fit in right here. This hydrogen is going to fit in right here. This hydrogen is going to fit in right here. The 4th hydrogen, because it is NH4, 4th hydrogen loses the electron just like it did up here to form the hydronium ion. So it's just going to lose that electron and it's going to come in and bond right there. And put that in brackets. Put a positive sign because it lost an electron. And everybody is happy. All right, everybody with me? Anybody not with me? Okay. Skip down to this one right here, NO2 minus, which this is called nitrite. All right, which do you think is going to go in the middle, nitrogen or oxygen?
Nitrogen.
The nitrogen. Nitrogen is farther to the left on the periodic table. Now, I'm going to write this in pencil, start off with, because there's going to be some erasing going on here. So nitrogen starts out with 5 valence electrons. All right. Each oxygen comes in right here. 1, 2, 3, 4, 5, 6. The other oxygen. 1, 2, 3, 4, 5, 6. Okay, everybody with me so far? If I understand how I got that, I got 5 electrons from the nitrogen, and I got 6 electrons from each oxygen. So these 2 have bonded, these 2 have bonded.
So it's okay that those 2 down there are alone.
Well, we're getting to that. So these ones that are down here on the bottom. Now, here's the thing. You have a lone electron here, here, and here. Pick 2 of them. Really doesn't matter which 2. I'm going to pick that one off the oxygen and that one off the nitrogen. And make that a double bond. Okay? And you have a negative sign right here. So what does that mean? I'm adding another electron, which is going to be added right here to satisfy that last oxygen. So this is what it ends up as. So put it in brackets and make that a negative sign. Now, we're not finished on that one. This is a special case because you see how I put the double bond right here? Couldn't I just as easily have put it over here? Like I had a choice to make. I could either put it here or here. Okay? All right. That means that you have something called resonance. Okay? Resonance. So, resonance means that it is shifting back and forth. Like it resonates back and forth. So, this double bond really doesn't exist right here, and it really doesn't exist right here. It's actually kind of shared between those two bonds. So what you have to do to indicate that is show the double bond here, and then also show the double bond on the other side. Okay? So it'll look like that with a negative sign. And that is your full structure, because it shows the double bond in both places. Now, the only time that you do that is when you have a choice with a double bond. So if there's not a double bond in the structure somewhere, there will not be a resonance structure. And not even everything that has a double bond has a resonance structure, but that's the only time that it would occur, is if it has a double bond somewhere, and the double bond could be on multiple places. All right, anybody have any questions? Okay, I want you to try to do those last three on your own. See if you can come up with those.